All right, here we go, guys and gals. So when we have oblique triangles, remember oblique triangle is a triangle that does not contain a right angle. We have to have a resource other than regular trigonometry with sine, cosine, and tangent. So last class we worked on a law of sines. During law of sines, I explained to you that there are four cases. Okay, there are four cases of non-right triangles that we can solve. The first two cases were for law of sines. Law of sines you used were angle, angle, side. So two angles in a side where the side was trapped and not trapped. Then you had that ambiguous case, SSA, the bad word, where there were several situations within that, but we were just only focusing on when the triangle actually existed. And that's when you had to use trig inverse to find those other two missing angles. Today, the last two cases are side, side, side. So if you don't have any angles, we're going to have to use something called law of cosines. Then if you only have one angle, and the angle is trapped between the sides, we have to use law of cosines, okay? So when you have all three sides or only one angle, we're going to be using law of cosines. And so I have a little bit of an introduction here to explain to you how does law of cosines work versus just saying, hey guys, this is the equation. So on your white piece of paper for the law of cosines intro, this is explaining here that, remember, we can turn any non-right triangle into two right triangles by drawing in the triangle's altitude. That's the height. Okay. And so it says let h be the triangle's altitude. So add h to your image there. Point D is where the altitude is going to intersect side CB. So this is going to be point D. X is going to represent the length of CD. So X is going to extend from here over to D. Now it says, what is the value of BD? So what was this whole side originally? A. C to D is going to be X. So DB is going to be A minus X. Good. The whole segment is A. This little piece is X. So this segment over here is going to be A minus X. So it's for triangle ABD, set up an equation for C squared. Okay, so this is a right triangle. Remember we put H here, and we had a D here. So for triangle ABD, what does C squared equal? Pythagorean theorem, right? Right triangle. H squared plus, what did we say this segment down here was again? It was A minus X actually. So it's going to be H squared plus A minus X squared. So the hypotenuse squared equals the sum of the legs squared. Now let's go the opposite triangle over here. For triangle ACD, set up an equation for B squared. Well, B squared equals, again, we said that this was X squared plus H squared. But then it says solve for H squared. So we want to get H. And actually, guys and gals, cross off the squared part. We're going to solve for H. So we're going to subtract this X squared off. So we're going to have B squared minus X squared equals h squared. And how do I get h by itself? What's the inverse of squaring? Square root. So h would equal the square root of b squared minus x squared. So h is not just h. H could equal this chunk right here. With that being said, it says number 5. Take your equation for number 3, substitute the value of h in, and simplify what you can. So we're going to plug in the value of h, and hopefully you would agree here then. If I plug that in for h, I would have the square root of b squared minus x squared. That's going to be squared because I'm replacing h. The other side there was a minus x squared, and we know that equals c squared. So what we're doing is we're relating the Pythagorean theorem to a non-right triangle. Okay? So let's talk about a few things. It says simplify what we can. If I am square rooting this chunk and squaring it, they are inverses of each other. I'd be left with b squared minus x squared. That cancels out. How many of you have ever double distributed before? So this says a minus x squared. I need to take this binomial times itself. I'm going to show you what that looks like over here on the side. A minus x times a minus x. So you need to take a times a and a times negative x. You also will take negative x times a and negative x times negative x. So double distributing. You may have heard an acronym in middle school called FOIL, first, outers, inners, last. To help you remember, you take this term times both and this term times both. Okay, you'll work on this a lot more in math too. All right, so a times a is a squared. A times negative x is negative ax. Negative x times a is negative ax. And negative x times negative x is positive x squared. Okay, so all of that goes right here. So I have an a squared minus it. Now, I have two of these. I have negative ax, negative ax. Those are like terms. It's going to be 2 ax's. And then my positive x squared equals c squared. So this chunk right here, these three terms came from double distributing here. Does anyone else see something that we could simplify? Emily?
The negative x squared and the x squared.
Good. The negative x squared and the x squared, they would cancel each other out. So this is what we're left with. B squared plus a squared minus 2ax equals c squared. Okay, very important stuff that we have right here. This is almost law of cosines. Number 6. For triangle ACD, set up an equation for the cosine of angle C and solve for x. So if I look back at my picture here, from angle C, right angle, what's my adjacent side? X, right? And this is B is my hypotenuse. So what would that look like? Would you agree the cosine of angle C equals B over X? or excuse me, x over b. Cosine of c equals x over b. Solving for x, how do I get rid of that divide by b? Multiply. So x equals b times the cosine of c. And lastly, number 7, replace your answer from number 6 into your equation for number 5. So I want to replace the x. So right here I want to replace this x with this. I'm going to show you that one more time. Circle that in your problem. You're replacing x with what x equals. So here is, everything we've done here is algebraic. I don't expect you to have this mastered, but I want you to know that this equation didn't come from nowhere. All right? So this is law of cosines. That c squared equals b squared plus a squared minus 2 times a. Now this is what we're replacing, and that was b times cosine of c. C squared equals b squared plus a squared minus 2ab times cosine of c. And after we use law of cosines today, you can come back to this. This might make a little bit more sense than the kind of glazed over Monday morning looks I'm getting right now. Okay? So again, when I was in high school, I was just told what this was. I didn't ever have anybody say, hey, you can start with this triangle, break it into right triangles. This is how the mathematicians came up with this, and it's mathematically true, okay, because it comes from those pictures. So revert now to your purple packet. Let's go ahead and write these out. So the good news is, guys and gals, this works for all of the sides of this oblique triangle, okay? And I think that you're going to very quickly see a pattern here. So let's say that I want to find side A first, or angle A. If I want to find side A or angle A, this is kind of what my setup would look like. So hopefully you recognize the Pythagorean theorem here. A squared, B squared, C squared. Okay? And I'm subtracting off. Now what letters are here? B and C, and they just came from here. And then it's cosine of what angle? A, and that is what it was out front, yes? So let's look at the next one. If I want to find B or angle B, this is what my setup would look like. So now I have B squared, A squared, C squared, and 2AC cosine of B. All right, I'm going to give you 10 seconds here, and I want to see if you can write what C squared would equal. Use this pattern and see if you can write what C squared would equal without looking at your white sheets. All right, how do we do? C squared equals A squared plus B squared minus 2AB cosine of C. Yep.
Do we have to write the 2 times B times C, or can we just write 2BC or 2AC or 2?
You don't have to have those time signs. When we plug these numbers in, you would have time signs or parentheses to show the multiplication, because those, when we're using these, they will be numbers. Now, as I started out by saying, we are going to use law of cosines for the third and fourth case, which is side, 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 or side, angle, side when you have one angle that's trapped. If the angle isn't trapped, you can use law of sines. This, I think you would agree, is longer. There's more steps. You can use law of cosines on the first two cases, guys and gals. However, okay, or on the second case for sure. However, it's quicker to use law of sines, setting those cross products equal to each other in one step. There's several steps involved here, okay? So that's what we're going to focus on getting through here is law of cosines now using a few examples. Now, law of cosines has a couple caveats. So a couple of the little caveats here is with law of cosines, you have to find the largest angle first because there are some special cases where that might be acute or obtuse. The largest angle might be acute or obtuse. And if you try to use law of sines to find the largest angle, you can't tell what the angle is, okay? So we always need to find the largest angle of law of cosines. And then once you find the largest angle, we can use the law of sines to find the other angles. But you don't want to find the smallest angle first with law of cosines because we always use law of sines second, and you could get the wrong answer. So we always want to find the largest angle first, unless you use law of cosines twice, which we won't do. And this is how I drew my triangle. So remember that we always put those values across. So side C was 14, side A was 8, and side B was 19. So we want to find the largest angle first. What angle do we have to find first? A, B, or C? B. Okay, and we know that B is going to be the largest angle because it's across from the largest side. Okay, so we're going to find angle B first, which means we're going to set it up as B squared equals. So 19 squared is going to equal 14 squared plus 8 squared. So B squared equals A squared plus C squared minus 2 times what? Do I use the 14 and the 8 again, right? Times 14 times 8 times the cosine of B. All right, so we want to get as close to an exact answer as possible here, so we don't want to round until the very end. The first thing you guys and gals are going to want to do is go ahead and take this chunk here, because those two chunks are being added together. So this is an option. In your calculator, you could type 19 squared minus 14 squared minus 8 squared and hit enter. And that would be this new value over here. Or if you want to be a little bit more comfortable with it, you could figure out what 19 squared is in your calculator, which is 361. Figure out what 14 squared plus 8 squared is, which is 260, right? Minus 2 times 14 times 8 times cosine of B. You could now take that 361 minus 260, which is 101. equals negative 2 times 14 times 8 times the cosine of b. My goal is to get b by itself. I'm going to multiply these values together. 2 times 14 times 8, which is 224. So I have 101 equals negative 224 times the cosine of b. I need to divide that chunk over, but I'm going to leave it as a fraction, right? Because it's times cosine. So cosine of b right now equals 101 divided by negative 224. I need to get b by itself, so what do I need to do? How do I get rid of cosine? Cosine inverse. So b is going to equal the cosine inverse of 101 divided by negative 224. What are you guys getting? Okay, good. I was getting 63 degrees and I knew that was wrong, but I forgot my negative sign. So, good. So the value of b would round to how many degrees? 117 degrees. Okay? So again, once you get 117 here, now you have an angle across from a side. I don't have to use this ginormous equation again. What could I use? Law of sines. So the sine of 117 over 19 could equal, we could do sine of a first, sine of a over 8. Raise your hand if you guys jump to what you could immediately type into your calculator. Let's write that down. Okay, you can write this, but please write down when you type in your calculator. So we have cross products, right? You're going to divide by 19, yes? So what would we type in our calculator? That a is going to equal the sine inverse of 8 times sine of 117 divided by 19. And this is where you guys and gals need to be really careful. You have to use lots of parentheses here, remember? And you would have another set of parentheses around that 117. So typing that in, measure of angle A equals what? $22. Measure of angle A is 22. I agree. Then if I wanted to find the measure of angle C, I'm just going to subtract from 180. And the measure of angle C would equal what? 41 degrees. All right, let's go through law of cosines one more time with this side, side, side scenario. We have to find which angle first. Okay, we have to find B first because it's the largest angle because 4 is the largest side. So we know that 4 squared must equal 2 squared plus 3 squared minus 2 times 2 times 3 times the cosine of b. Now, this is kind of the work that I do. In my calculator, I would find 4 squared minus 2 squared minus 3 squared. So this is what I was talking about earlier. I take this 16 minus 4 minus 9 and get rid of, I simplify this up. What is that? 3. Okay, so 3 equals, then I go ahead and I type this, sometimes I type this into my calculator then, negative 2 times 2 times 3. So I simplify this chunk here. So I simplify this here, which is negative 12 times cosine of b. And again, this chunk right here, I simplified that to get my 3 here. Okay? And then I have still that cosine of b. So now to get b by itself, I need to divide the negative 12 over. So cosine of b, or b equals, can we jump to that? B equals the cosine inverse of what? 3 divided by negative 12, yes. It's a positive 3 on top though. Okay, so divide by that negative 12 to get b by itself, you have to do the cosine inverse. So cosine inverse of 3 divided by negative 12. Again, this is an obtuse angle, 104.47. So that would stay at 104 degrees. Measure of angle B is going to stay at 104 degrees. Now, again, to use, we could find angle A next. I could say 4 over the sine of 104 equals 3 over the sine of A. Right? So I'd have my cross products here, and then I'd have to divide by the 4. So angle A is going to equal the sine inverse of 3 times the sine of 104 divided by 4. What are we getting here? What do we say? 47. I agree. 46.6957 is going to round to the measure of angle A is going to equal 47 degrees. So then the measure of angle C leaves us with what? 29 degrees. All right. Now, so that's on side, side, side. We had to find the largest angle. The last case here is side, angle, side. So on side, angle, side, it's possible that the largest angle might be acute or obtuse, and again, we can't tell from the law of sines. So what we're going to do here is we're going to find the smallest angle first because we know it has to be acute. Because I can't have more than one obtuse angle in a triangle. So on side angle side, we're going to find the smallest angle first because you know it has to be acute. So let's look here. I have when we go to law of sines, you're going to find that smallest angle first for sure. Okay, so first though, I have angle 55. So I have to find A. And I can't use law of sines because I don't have two angles. Okay, so I have to find side A first. So here we go. A squared equals 3 squared plus 10 squared minus 2 times 3 times 10 times the cosine of 55. A squared equals 3 squared plus 10 squared minus 2 times 3 times 10 times the cosine of 55. Hey, Isaac, you want to swing that door shut? So there's a lot less work to start at the beginning of this. We want A by itself, okay? But we want to type all this into the calculator at once. How do I get A by itself? How do I get rid of the square? Okay, so this is what you're going to write on your paper. A equals the square root of 3 squared plus 10 squared. You're just rewriting this. Minus 2 times 3 times 10 times the cosine of 55. You okay with that? Why I have what I have written in red? And that's what you get to type in your calculator. You type it all in together. Go ahead and type it in and make sure that you know how to get the square root sign and get the exact correct answer. Are we getting 8.6? So you type this in and you're getting 8.6 for this side over here. So now I need to find, with law of sines, I have to find the smallest angle first. Now that I know what this side is, I'm going to find angle B or angle C. All right, so angle C is going to be the smallest angle out of those sides because it's the angles because it's the smallest. It's across from the smallest side. So with that being said, I know that I need to use 3 and the sine of C. And I don't know what angle B is yet, so I'm forced to use the 8.6 we just found over the sine of 55. So guys and gals, it's really important that you type this all in correctly and get A correct, otherwise C is going to be wrong. So cross products multiplied, you'd be dividing by that 8.6. So the C equals the sine inverse of 3 times the sine of 55 divided by 8.6. So that's going to round up to 17 degrees, right? So then lastly, the measure of angle B equals what? 180. minus 55 minus 17, 108 degrees. All right, I'm going to go ahead and show you how to set up number 4. I think we're doing okay on this now. So again, 108 for measure of angle B. I have to find side T first, okay? So T squared would equal 46 squared plus 60 squared minus 2 times 46 times 60 times the cosine of 45. So again, what you're going to type into your calculator, let's practice this one more time. T is going to equal the square root of 46 squared plus 60 squared minus 2 times 46 times 60 times the cosine of 45. We've practiced the law of sine several times today. The measure of angle P, you can write down, is 85 degrees, which would leave us with the measure of angle A as 50 degrees. We are going to save the last word problem there for next class.